Hello everyone, I am Vinay and we are a team of three members that includes Shiva, Aditya Rao and myself. First of all, we are thanking Embedded Information Technologies for providing with an internship opportunity and we will be presenting what we learned during this internship period. So uh, today we are presenting on IoT based home automation solutions. So let's get started. So during week one, we have learnt about C programming, and in week two, C++ programming, and in week three, project requirement and design Arduino programming, and in week four, building the units that peripheral programming. In week five, we have learnt about project integration and testing. So let us enter into topics in C programming. So introduction to C and data types. So as we know, C is a general purpose procedural imperative computer programming language developed in 1972 by Dennis Ritchie at Bell Labs. Uh, Generally, it is one of the most widely used programming languages and has had a significant influence on the development of other programming languages. So the general key features of C language is efficiency, portability, and flexibility. And in types in C, data type is a classification of data based on its format, size, and set of values it can hold. Uh, there are data types, they are integer types, floating point data types, character data types, void data types, derived data types that are example arrays, pointers, structures, and unions, and etc. Uh, Next, coming to conditional constructs. A conditional constructs in C allow you to control the flow of the program based on the conditions or decisions. So the general conditional constructs in C are if statement, if else statement, and if else statement, and switch statement. Uh, Generally, the if statement is used to execute a block of code if a certain condition is true. And if else statement, whereas if else statement is used to execute one block of code if a certain code condition is true and another block of code is condition is false. And if else statement, the if else statement is used to check multiple conditions and execute different blocks of the code based on those conditions. And coming to switch statement, the switch statement is used to execute different blocks of code based on the value of a variable or expression. uh, Next, enter into arrays and operators. So operators in C are symbols used to perform operations on variables and values. So generally, operators are arithmetical operators, relational operators, logical operators, assignment operators, increment and decrement operators, and bitwise operators. So as we came across these topics, like arithmetic operators means plus, minus, multiplication, division, and relational operators means equal to, not equal to, greater than, less than. And logical operators are logical and, logical or, logical not. And various arithmetical assignment operators are assignment, addition assignment, subtraction assignment, multiplication assignment, division assignment, and modulus assignment. And increment and decrement operators. And bitwise operators means bitwise and, bitwise or, bitwise XOR, bitwise not, left shift and right shift. And coming to arrays, arrays in C are collection of elements of the same data type stored in memory locations. Uh, and next, coming to pointers, pointers are variable that stores memory addresses as their values. These are used to indirectly access and manipulate the data stored in the memory locations they point to. And coming to functions, functions are generally a block of code that perform a specific task. These are used to organize code, reduction, repetition, and improve modularity. And next, coming to recursions and functions. Recursion is a programming technique where a function calls itself repeatedly until it reaches a base case that stops the recursion. Here is an example of recursion that calculates the factorial of a number. And generally, the key elements of a recursion are base case and recursive call. And examples, we have came across those. General function. Functions in C are block of code that performs a specified task. They can take arguments, return values, and be reused throughout a program. And coming to pointers and strings, in C, strings are array of characters generated by a null character 0. Uh, Pointers can be used to manipulate strings and access their characters. Uh, Next, coming to preprocessing. Uh, Preprocessing is a step in C compilation process that occurs before the actual compilation. The preprocessor reads the source code and perform preprocessing directives and generate a modified source code that is then compiled. Generally, examples of preprocessor directives are hash include stdio.h and hash define if def if and def and hash if hash else uh, hash elif etc. And macros are defined using the hash define directive. And header files contain function declarations and macro definitions that can be shared among multiple source files. And essential of C++. Uh, C++ is a high performance general purpose programming language that was developed by uh, Shrostrup at Bell Labs. It is an extension of the C programming language and adds object-oriented programming language. Objects and classes in C. In C++. In C++, a class is blueprint for creating objects. A class defines the properties and behavior of an object, while an object is an instance of a class. And constructions in C. Constructions are special member functions that are called when an object is created. They are used to initialize objects with the specified values. And next, coming to project requirements and design Arduino programming. Introduction to IoT. IoT means generally the Internet of Things. IoT refers to the network of what we can say physical devices, vehicles, home appliances, and other items that are embedded with sensors, software, and connectivity, allowing them to collect and exchange data with other devices and systems. Uh, Key features of IoT are interconnected devices, sensing and actuation, data analysis, and automation. Project requirements for IoT. Uh, Project requirements of IoT are device selection, connectivity, data management, security, power management, and user interface. Introduction to embedded systems. Uh, Embedded systems are specialized computer systems designed to perform a specific task or function within a larger system or device. They are typically embedded with a device or system and are designed to operate autonomously without human intervention. Generally, the characteristics of embedded systems are real-time operation, resource constraints, specific functionality, reliability, and applications of embedded systems are consumer electronics and industrial control systems and automotive systems and medical devices. Next, coming to LED programming. LED program involves controlling LEDs using microcontrollers or other programmable devices. Uh, Generally, we know LEDs are light emitting diodes that are made up of a semiconducting material. Uh, Next, how to upload the hex file CLC interfacing. So, to upload X file or a microcontroller, you need a microcontroller programmer and a programming software. And CLCD interfacing. CLCD means character liquid crystal display. Interfacing involves connecting a CLCD module to a microcontroller to display text or characters. Generally, the CLCD pin out for VCC means power supply. and GND ground, SCL clock signal, SDA data signal, RS register selector, and RW read or write, and E enable signal. Next, CLCD programming. CLCD basics. CLCD modules display text or characters using a matrix or crystal or matrix of liquid crystals. Next, coming to building the units, peripheral programming. Uh, just now we come across CLCD programming and ADC, analog to digital converter. An analog to digital converter ADC is an electronic device that converts an analog signal, or generally you can say it as continuous signal, into a digital signal. Into a digital signal. It is also known as a discrete signal. This conversion is necessary because most of the microcontrollers and data systems can only process digital signals, and the, uh, ADC means generally the analog to digital converted works on sampling. The ADC samples the analog signal at regular intervals, and quantization. The ADC assigns a digital value to each sample based on its amplitude, and encoding. The digital value is then encoded into a binary format. Uh, Next, coming to temperature sensor. A temperature sensor is a general device that measures the temperature and converts into a electrical signal. Uh, some examples of temperature sensors are thermistors, thermocouple, and LM35, and PWM module. PWM module is a device that generates a pulse width modulation. PWM is a technique used to encode a message into a pulsing signal. It is commonly used to control the speed of the motors, or the to control the brightness of LEDs and power delivered to a load. And controlling LED using LDR. Uh, LDR is a type of resistor whose resistance varies depending on the intensity of light falling on it. By using LDR in a circuit with an LED, we can create a simple light sensitive switch that turns the LED on or off based on the light intensity. And next, coming to serial tank programming. A serial tank programming involves controlling a tank's movement and actions using serial communication. And next, coming to integration and testing, uh, using Blink app configuration, uh, we have made controlling heater, cooler, and reading temperature using Blink, and displaying notification on CLCD, and configuration of a serial tank. And requirements of this project: controlling brightness of the garden lights using LDR sensor and Blink IoT. It is a mobile application. And controlling room temperature using temperature system and Blink IoT. Measuring and controlling volume of the water in water tank using serial tank and Blink IoT. And garden lights control, LDR sensor. LDR defined as the light dependent resistor. It is a component that has variable resistance that changes with the intensity of the light that fall upon it. LDR are often used in circuits where it is necessary to detect presence of level of lights. And this is the block diagram of Arduino Uno and LDR sensor. The output of the output of LDR sensor is given to ADC, means analog to digital converter, which is inbuilt in Arduino Uno. Uh, in Arduino Uno, what happens is, if there is a less light, more resistance and less voltage, and if there is a more light, less resistance and more voltage. Next, Aitara will continue. Thank you.
Thank you, Vinay. From now, I shall continue the presentation. So, the output which is given to the ADC ranges from 0 to 1023. When the output voltage of the ADC is 0, which means there is less light in the environment, then the brightness of the garden light should be more, means they should be full bright. When the voltage output is 1023, which means there is a lot of light in the surrounding, it means the brightness of the garden light should be less, that is 0. Now converting this output voltage of ADC to brightness of the LED. So this conversion happens as I have told you that the output of ADC is from 0 to 1023, from 0 to 1023. Now when it is 0, it means there is no light outside. So we have to turn on the LED with the maximum brightness. So when the output is of ADC is 1023, then the input voltage for LED should be 0. Let us derive a formula for it, that is the conversion formula. So the input value is obtained from the analog read function, where we write the pin number of the LDR, that is analog underscore LDR, and this reads the values from 0 to 1023. Now input value is equals to the obtained output of the ADC divided by 4, which means we are converting from 0 to 1023 to 0 to 255. Now, as I have told, we have to reverse them. So, we have to subtract it from 255, which converts high ADC values into low input voltage of LED and vice versa. Now, let us see how it works. For example, firstly, we have taken the ADC output is 0, which means the environment is dark. So, our input to the LED should be high. So as I've told in the previous formula, firstly we have to divide the ADC output by 4. So we get again 4, 0. Now we have to subtract it from 255. Then we get 255, which means the high input voltage to the LED. Now when the ADC output is 1023, which means the surroundings is bright, so we want our garden lights to be turned off. So firstly we have to divide 1023 by 4, we get 255. Now we have to subtract this 255 by the 255, we get 0, which means we are giving low voltage to the LED input, which means our garden lights are turned off. Now here is a pictorial representation of our simulation. Here when the resistance of the LDR is low, our LED will be on. When it is medium, it will be on with less brightness. Now when the resistance is more, the LED brightness will be more. Let us see its code and simulation. Coming to the code of LDR, firstly we have given the pins that for LDR sensor is A1 and for the garden light we have given the pin 3. Here firstly we have the initialization of LDR function. Here we use the pin mode keyword, and here we given the garden light, which is the pin of the garden light where we have given it is as 3, and then it is given as output. Then we write the main code to control the brightness of the LED, that is garden light. Here is the formula that I have just now told you, that is analog read, and then we have to divide it by 4 and subtract from 255, and then we have to write this to the LED, that is using the analog, right? Similarly, we have to initialize it in this main code. At the void setup, we have to initialize LDR and then brightness control in the loop also. Let's see the simulation. Here you can see when the resistance is more, our LED glows brightly. When we reduce the resistance to half or even, the brightness of the LED is decreasing. Even more, it decreases even more. Now, when the resistance is completely zero, then the LED is completely turned off. So this is the simulation of our garden life. Now coming to the next topic of our project, it is temperature control system. In this temperature control system, we use LM35 temperature sensor, and we use heater and cooler switches to turn on and off to control the temperature of the room. So this can be controlled by Blink IoT app, and the notifications will be displayed on CLCD simultaneously on the Blink IoT app. Coming to the block diagram, here firstly in the temperature system, from the temperature system we obtain the temperature to the Arduino Uno, and this is displayed on Blink IoT as well as on the CLCD. And the heater and cooler controls are in the Blink IoT app. From this Blink IoT, they are transferred to Arduino Uno and then they are controlled in the temperature system. Coming to the LM35 temperature sensor, it is linearly proportional to the centigrade temperature. So whenever the voltage output from the LM35 sensor is more, it means temperature is also more. When it is low, it is low. Coming to the output voltage of ADC, here also similarly we have a formula to convert this 0 to 1023 analog values into temperature. Here we use temperature is equals to analog read A0. Here A0 is the pin of the temperature system which we have given to the Arduino. From that analog read, we have to multiply it by 5 and divide it by 1023 because there are 1024 samples. Next, we have divided by 0.01 millivolts. And here you can see the syntax of the analog read and pin number. Now, based on the temperature value we get on the CLCD and Blink IoT app, as per our wish, we can control the heater and cooler switches, and these will be displayed on the CLCD. And we also want to keep a condition that when the temperature increases more than 35, we want heater to turn off. So let us see the code. Coming to the temperature system, here I have told you the pin numbers. For heater we have given 4 and for cooler 5. For the temperature sensor we given A0. Now in the temperature system code we have given firstly initialization of the temperature system and we given outputs for heater and cooler. Then we wrote a function to read the temperature and we wrote the same formula which we discussed previously. Then we want to control the cooler. The cooler control option is this. When the control is on 1, when the control is set to be 1, then the cooler will be on. When the control is 0, the cooler will be off. Similarly for heater also. In the main Blink IoT app also, we write to display them on the Blink IoT app. Similar the blink right and blink right for cooler for heater. And here is the code for the displaying them in the CLCD. That's all about the code. The further will be presented by my friend Shiva.
Thank you, Aditya. I'll be explaining about Blink IoT app and simulation of temperature system and serial time. Blink IoT app was used to control IoT gadgets. It can control hardware remotely, display the sensor readings. We'll be using two widgets, button widget and gauge widget. Button widget is used as switch to control heater, cooler, inlet valve, outlet valve. Gauge widget is used to display the temperature and volume of the water in the tank. When the heater is on and the temperature is above 35 degrees Celsius, heater will automatically turn off and heater off is displayed in the CLCD. The disadvantages of Arduino Uno board is we don't have a Wi-Fi built-in module in the Uno board, so we will be using Ethernet shield to communicate externally. Coming to controlling the temperature system, this is the temperature system. We'll be seeing that cooler on, and heater off on the simulation. This is the Blink IoT app interface. Here you can see heater, cooler, inlet valve, and outlet valve widgets, and volume and temperature gauges. I'll try to simulate it using PiximLab and my mobile Blink IoT app. I'll be turning on the heater using Blink IoT app. You can see that heater on and temperature is increasing. The temperature reaches 35 degrees and automatically heater will be turned off. You can see that heater is off automatically. I'll try to on cooler switch. The cooler is on. You can see that the fan is rotating and the temperature is decreasing in the temperature system. I'll try to turn off the cooler. We'll be going back to the presentation. Serial time. It is called serial time because we will be communicating in serial manner. Will we try to use inlet valve and outlet valves of the serial tank to control this? Coming to controls of the serial tank, if the inlet switch is on, the volume of the water increases, and if the outlet switch is on, the volume of the tank decreases. If the volume of the water is below 2000 liters, the inlet valve will be automatically turned on. If the volume of the water is above 3000 liters, inlet valve will be automatically turned off and same will be shown on CLCD. These are the pictures of simulation. Inflow on, outflow on, volume is shown here. We'll be seeing same on the SimLab and Blink IoT app. I'll be opening the serial time. I'll try to on inlet valve. You can see that inflow is on and volume of the water is increasing. I'll turn off the inflow. I'll turn on the outflow. You can see that decrease in the volume of the tank and outflow is on. I'll try to turn off the outflow. Coming to skills acquired, C programming, introduction to C++, introduction to IoT, project requirements and design, introduction to embedded system, IoT, Arduino programming, Blink app configuration, installation of SimLab, Arduino IDE, and we'll be using serial tank, LCD module, ADC module, PWM module, serial communication using Ethernet shield and serial tank, controlling of devices using Blink app through Blink Cloud Serial IoT,